Once again, welcome to my channel, that is HAT Chemistry. Dear friends, today I am going to discuss about different types of organic chemical reactions. Organic chemistry is a very big subject or a very vast subject. There are 5 crore of organic chemistry already synthesized or discovered, and thousands of organic chemical reactions also there. By hearting all these things is not an easy job. Therefore, but you can study this subject very easily if you understand that almost all the chemical reaction in organic chemistry comes under the category this one. Addition reaction, elimination reaction, substitution reaction, rearrangement, oxidation, reduction, extrusion, name reaction. Moreover, a few photochemical reaction is there, etc. But almost all chemical reaction comes under this category. Now look at what is the peculiarity of these reactions. First of all, addition reactions. I have drawn an example or a general picture of an addition reactions. You can say that into this unsaturated compound, that means an alkanes, I am adding XY. X is goes to here and Y is goes to here, you will get the product. During this chemical reaction, you can see that unsaturated compounds become saturated. Now, how can we represent an elimination reaction generally? Is a molecule A and B is there. This on chemical reaction in presence of a reagent, A and B will be removed from here. Due to this, a double bond is formed. That is, this saturated compounds becomes unsaturated. That means addition and eliminations are opposite reactions. Now, there is a substitution reaction is there. RXY gives RYX. Here X is substituted by Y. I told you that substitution reaction we can again classify into different types, nucleophilic, electrophilic, etc. But generally you can say substitution reaction is RX. In this RX, X is replaced by Y, you will get RY plus X. Then rearrangement reaction, lot of chemical rearrangement reaction you have to study in your studies. Generally I can say that WAB. Here the arrangement of group is nothing but WAB. On rearrangement, you will get WBA. Then you on your studies, you can see a lot of oxidation reaction. Generally, oxidation is nothing but addition of oxygen or highly electronegative atom or removal of hydrogen. Reduction reaction is there. Reverse of the oxidation, that is the addition of hydrogen or removal of oxygen or highly electronegative atom. Extrusion reactions. X, Y, Z. If this is the compound, if a Y is extruded from this molecule, you will get XZ plus Y. Lot of name reactions are there that also you have to consider. Mainly, if you study these reactions in a few extent, you can understand organic chemistry very easily. I have told you that there are a lot of reactions. Today I want to give you a very few idea regarding on different types of reactions. First one, that is addition reactions. Basically there are 3 types of addition reactions. One is we call it as electrophilic, nucleophilic and free radical addition reactions. How they are classified, that is our next aim. I will give an example. CH2 double bond CH2 plus HCl is an example of hydrohalogenation reaction. You will get the answer CH3 CH2Cl is the answer. Here actually in this reaction you are adding H plus and Cl minus is adding in this reaction. In this reaction you are adding H plus and Cl minus is adding. We know in chemistry there are 2 types of reagents. One is weak attacking reagent. We call it as electrophile. Next one is we call it as nucleophile. Electrophile is nothing but electron loving. In simple sentence, simple way, you can understand electrophile sometimes have a plus charge, or if the reagent have a plus charge, definitely that should be an electrophile. If it have a negative charge, definitely that will be a nucleophile. Actually, in this chemical reaction, you are adding both H plus and Cl minus. That is both electrophile and nucleophile. Nevertheless, it is known as electrophilic additions. Electrophilic addition. Why so? It is because this chemical reaction takes place in two steps. In the first step, CH2 double bond, CH2 plus H plus, you will get the answer, that is CH3. I means this two electrons goes to here. You will get a negative charge. The H plus is added. Due to this, you will get CH2 plus CH3. And the next stage, Cl minus is added. You will get the answer CH2Cl CH3. That means here both electrophile and nucleophile is adding, but it is known as electrophilic addition. It is because this reaction takes place in two steps. Whatever it may be, if the reaction takes place in number of steps, definitely one of the step is, you can take it as one of the slowest step. Therefore, here it is the slow step and it is the fast step. You know, rate determining step is slow step. In the slow step, H plus is added or electrophile is added. That is why it is called electrophilic addition reactions. Similarly, come to these examples. You know, you can find that to this C double bond O, H plus and Cn minus is added. H plus goes to here and Cn minus goes to here. Here also you can find that both the electrophile and the nucleophile is adding. Nevertheless, it is known as nucleophilic addition. It is because this chemical reaction also takes place in two steps. In the first step, Cn minus added to here. Then you will get one addition of Cn minus. You know, the pi electrons goes to here. Therefore, a positive charge is created here. Cn minus goes to here. You will know that is CH3, that is CO minus Cn, then CH3. And in the next stage, H plus is added, you will get the product. This step is taken as slow step. This is the fast step. You know, in the slow step, nucleophile is adding. That is why this reaction is known as nucleophilic addition reaction. Addition to keto group is usually nucleophilic addition reaction. But addition to an alkene is usually electrophilic addition reactions. One more thing is that is, so electrophilic addition reaction, you have, you know, a very famous rule is there, that is we call it as Markovnikov rule. I will give you a lesson, a separate lesson on electrophilic addition. At that time, I will discuss that Markovnikov rules. Now, free radical addition is the third one. CH2 double bond CH2 plus HBr. In presence of peroxide, you will get the answer. It is known as free radical addition because in presence of peroxide, a Br free radical is formed. That Br free radical is added to this one. You will get CH2 free radical, then CH2Br, and next stage H is added. You will get the product. Here also, since free radical is adding, that is why it is called free radical addition reactions. That is about the addition reactions. The second type of reaction is elimination reactions. Basically, in chemistry, you have two types of elimination you have to study. One is we call it as beta elimination. Next one is alpha elimination. What is beta elimination? What is the difference between beta elimination and alpha elimination? You know, when this compound on reaction with alcoholic NaOH, NHCl will be removed. The removal of HCl is just like this way. Chlorine is removed from here. The carbon attached to the most important group is, we call it as alpha carbon. Its nearby carbons, we call it as beta carbon. Here, chlorine is removed from here. Hydrogen may be removed from here or here. First type of reaction is we call as beta elimination. That is, hydrogen is removed from beta positions. Here there is two possibility of the product. One is this product. Next one is this product, because if hydrogen is removed from here, you will get this product. This is actually the major product. This is a minor product. The majority and minority of the product is decided by a famous rule, that is, Zaitsev rule. That type is we call it as beta elimination reactions. Now, what is alpha elimination reaction? This type of reaction you can see in the Reamer-Tiemann reactions. A byproduct is if you study the mechanism of Reamer-Tiemann reaction, there is a reaction intermediate, we call it as carbene, are formed. This is a carbene. Methyl carbene is here. The removal is just like this way. Reaction with the KOH, chlorine is removed from here, hydrogen is removed from here itself. This we call it as alpha carbon atom. Chlorine and hydrogen is removed from the same carbon atom. That type of elimination is we call it as alpha elimination. That is about the elimination reactions, right?